Hey guys, I'm Bhavya. I'm an instructor at Skiller Academy. In this video, I will discuss the problems of code drift. So this contest was on maths this time, and I'll discuss the first two problems in this video, which will be the very easy problem and the medium problem. So let's look at the very easy problem first. A shopkeeper sells daily A units of item, and his shop remains closed on weekends, that is Saturday and Sunday. We need to find the number of weeks it will take to sell B units of them. Assume that the first day will be Monday and then return the seal value of the number of weeks. For example, if it takes 9 days to sell all units, then return 2 weeks. So for example, if
A is 3 and B is 7.
that is each day we sell 3 items and we need to sell 17 items in total. So on the first 5 days, shopkeeper can sell 15 items. After that, we will have a weekend, which will be Saturday and Sunday. So on 8th day, we will sell the remaining 2 items. So the number of weeks required is actually 2. So let's look at the solution outline. So actually first let's find the number of days it will take to sell all the items. So since we are selling A items each day, so we'll keep selling A items each day, and we will do that until this value actually becomes greater than or equal to weeks. So for example, if the total number of items are 17 and we sell 3 items each day, we will sell 3 items the first day, then 3 items the next day, 3, 3, 3, so on up till the items become 15, and now we'll only sell 2 items. So we can say that the total number of days required will actually be seal of B by A, where seal is the smallest integer greater than or equal to B by A. So for example, for 17 by 3, this will be 6, because this is the smallest integer which is greater than or equal to 17 by 3, because the value of 17 by 3 is something around 5.6666 and so on. So now we know the number of days. To find the number of weeks, we can actually use a similar idea, because we know that in a week, we will only open the shop for 5 days. So the total number of days will be seal of days by 5. And to calculate the seal of P and Q, so if we need to calculate the seal of P by Q, we can actually use the formula P plus Q minus 1 by Q, where this is the integer division. So for example, for 17 by 3, this will be 17 plus 2 by 3, which is 19 by 3. And this will be 6, because we are only calculating the integer division. So let's actually implement this. So we assign days as B plus A minus 1 by A, which is seal of B by A. So days is seal of B by A. And we will simply return days plus 4 by 5, which is seal of days by 5, which is our answer. So let's actually submit it to check. So we have written the code here and it works on the sample cases, and let's submit it. It works on all the cases. Now let's look at the second problem, which was the medium problem, count good subsequences. So an array is good if all the elements present in it have the same frequency. For example, 2, 3, 3, 2 is good because both 2 and 3 have frequency 2. 2, 3, 2 is not good because the frequencies of 2 and 3 are 2 and 1 respectively. You are given an array A, you need to count the number of non-empty subsequences which are good. So since the answer can be large, you need to return it modulo 10 raised to 9 plus 7. And the length of A will be around 2 into 10 to the power 5, and the length of AI will be between 1 and 10 to the power 9. So we need to find it modulo 10 raised to 9 plus 7. So for example, if A is 1 to 1, the total number of good subsequences will be 6, because all subsequences of length 1 are good because the frequency will be 1. Similarly, all subsequences of length 2 will be good, because for the array subsequence 1 2, the frequency is 1. For the subsequence 2 1, the frequency is 1, and for the subsequence 1 1, the frequency of all elements is 2. But the array of length 3 will not be good, because the frequency of 1 is 2 and the frequency of 2 is 1, which is not equal. So the total number of subsequences which are good are 6. So let's look at the model solution. So let's actually take a bigger array, 2, 5, 3, 2, 3, 5, 7. Let's actually add another 2. So since we need to find subsequences, we can actually ignore the order of elements, because the subsequence is equivalent to choosing some elements out of the given elements, and the order here does not matter. So we can actually sort this array. So this will be 2, 2, 2, 3, 3, 5, 5, 7. So what we'll do is, instead of iterating all the subsequences, we'll fix the frequency f. F is the frequency of all the elements present in the subsequence. So for example, if the subsequence is 2, 2, 3, 3, and we know that this is good because the frequency of 2 is 2 and the frequency of 3 is 2. So f will be 2 for this case, because all the elements have frequency 2. So we are actually fixing the frequency f of all the elements present in the subsequence. So let's say f is 2. If f is 2, how many subsequences will be there such that all the elements have frequency 2? So consider the element 2. There are 3C2 ways to select 2 elements whose value is 2. But we can also ignore the element 2. So there is one way to actually ignore them. And if we want to take it, there are 3C2 ways. Similarly, consider 3. There is one way to ignore it, that is to discard the elements 3. And if we want to take it, we will have 2C2 ways, because we have two elements whose frequency is 3 and we want to take two of them. So there will be 2C2 ways. Similarly, for 5, the number of ways will be 2C2. And for 7, the number of ways will be 1 plus 1C2, and 1C2 is actually 0. So this will be 1. That actually means that we can only ignore the element 7. We cannot take it because the frequency is 1, and we cannot select two elements because we only have one element. But notice that we need to subtract 1 here as well, because we have to subtract the case where we ignore all the elements. That is, we get an empty subsequence and we only need to count non-empty subsequences. So I'll subtract 1 here. Now let's actually do it for any general f. So if our frequency is, so from here you can notice that we only care about the frequencies of elements, not the values of elements. So let's store the frequencies of elements f1, f2, f3 and so on up till fk in sorted order. So for example, here the frequencies are 3, 2, which is the frequency of 3, 2, which is the frequency of 5, and 1, which is the frequency of 7. So we'll store this list in sorted order 1, 2, 2, 3, and the sum of these frequencies will be equal to the length of this array. So because 2 plus 2, which is 4, 5 and 8, and the total number of elements are 8 here as well, because the sum of frequencies of elements will be equal to the total number of elements. So we are storing this list in sorted order f1, f2, f3 and so on up till fk. So let's actually fix f. All the elements will have frequency f, and we know that the number of such subsequences will be 1 plus f1 cf into 1 plus f2 cf. That means that we can either ignore this element, and there is only one way to ignore it, or we can select f elements, which will be f2 cf, and so on up till 1 plus fk cf, and we will subtract 1 here as well. So this gives the total number of subsequences for any f, and we will do that for all f from 1 to fk, because after that we cannot have f as fk plus 1 because the maximum frequency is fk. And we will simply add this value. For all f, and this will give us the total number of subsequences. Now let's actually think how fast this actually is. So if we were to know a way to calculate NCR in O of 1, so let's say we know that we can calculate NCR in O of 1 using some pre-processing. I'll describe it later, but let's say we know that. So we can actually calculate NCR in O of 1 with some pre-processing. Now how fast calculating this formula will be. So notice that if our frequency was 2, 3, 5, 7, 8 or something like that. Let's say our frequency is 2, 3, 5, 7, 8. And we are considering f equal to 4. So if we are considering f equal to 4, we only need to consider the elements 5, 7 and 8, because for 2 and 3, this value will be 1 plus 2c4 into 1 plus 3c4. And we know that NCR where n is less than r will be 0. So this will only contribute 1 to our product. So we can actually ignore these two elements. And since we have sorted this frequency array, we can find the first element which is greater than or equal to 4 using binary search. So we can use binary search to find the first element which is greater than or equal to 4, which will be 5 in this case. So now let's actually find what will be the contribution of each element. How many times will each element be considered in our formula? So if we have a sorted array of frequencies f1, f2, f3 and so on up till fk, fi will only be considered for all the f from 1 to fi, because after that this term will only contribute 1, because we know that 1 plus the contribution of this fi will be 1 plus fi cf for all the f, and if f is greater than fi, this value will be 0, so this will only contribute 1, and we will ignore that, as we said here that for f equal to 4 we will ignore 2 and 3. So this fi will only be considered fi times. So our total time complexity will be sigma fi, which is n, because we know that the sum of frequency is n. So to make it more clear, considering this example 2, 3, 5, 7, 8, for f equal to 1, we'll consider this element, this element, this element, this element, this element. So all the elements will be considered for f equal to 1. For f equal to 2, again we'll consider this element, so this will be considered twice now, this will be considered twice, this will be considered twice, this will be considered twice, this will be considered twice. For f equal to 3, we will actually not consider 2 because this is lesser. So the next element which is greater than or equal to 3 is 3. So I'll only consider the elements from 3 to 3, 5, 7 and 8, and so this will be considered thrice, this will be considered thrice, this will be considered thrice, and this will be considered thrice. For f equal to 4, we'll only consider 5, 7 and 8, so all of these elements will now be considered 4 times. For f equal to 5, we'll consider 5, 7 and 8 again, so this will be considered, all of these elements will be considered 5 times now. For f equal to 6, we'll consider only the elements 7 and 8, so they will be considered 6 times both. For f equal to 7, again both the elements will be considered, so both these elements will have been considered 7 times now. For f equal to 8, we'll only consider this 8, and so this will be considered 8 times now. So you can see that each element is considered equal to the value. So fi will be considered fi times. So the total time complexity is O of n here. But now, how to calculate NCR in O of 1 with some pre-processing? So we know that NCR is equal to n factorial upon r factorial upon n minus r factorial. So what we'll do is actually store all the factorials from 1 to n, and we know that factorial of I is equal to I into factor of I minus 1. And this can be done using a single loop. And we'll actually obviously do this calculation modulo mod, which is 10 to 9 plus 7 in our case. And to calculate inverse of factorials, so we know that if we know fact of n, to calculate inverse factorial of n, what we'll do is we'll calculate factorial raised to mod minus 2 modulo mod using Fermat's theorem, because we know that the inverse of a modulo prime number p will be a raised to p minus 2 modulo mod. And a raised to p minus 2 can be calculated using binary exponentiation. So this will be inverse factorial of n. So we can calculate inverse factorial of n using this way. So this will be O of n, and this will be n log mod, because we are doing binary exponentiation, and we know that binary exponentiation will take log of power time, which is log of mod here. But this can actually be done fast. So if we can calculate inverse factorial of n using binary exponentiation, what we can do is to calculate inverse factorial of n minus 1, we can multiply inverse factorial of n with n and then take the modulo. So this will give us inverse factorial of n minus 1. This is because inverse factorial of n is 1 upon n factorial, and we multiplied by n, and this will give us 1 upon n minus 1 factorial, which is equal to the inverse factorial of n minus 1. So we'll actually look at the code to make it more clear, to make all the ideas combine all the ideas and make it more clear. So here our solution starts. We'll pre-process, that is, we will calculate the factorials and inverse factorials. So our pre-process, we store an array f, which is the factorials, and an inverse, which is inverse factorial. So f of 0 is 1, because you know f factorial of 0 is 1. And now we'll iterate from 1 to n and assign f of I as I into f of I minus 1, because that's the definition of factorials. And now we assign inverse factorial of n minus 1 as factorial of n minus 1 raised to m minus 2, and that can be done using binary exponentiation. Now for calculating inverse factorial of I, what we'll do is we will use inverse factorial of I plus 1. So inverse factorial of I will be I plus 1 into inverse factorial of I plus 1, because inverse factorial of I plus 1 is 1 upon I plus 1 factorial, and we'll multiply I plus 1 into it, and that will give us 1 upon I factorial. So in this way we can calculate factorials and inverse factorials, and the time complexity of preprocess function will be O of n for calculating all the factorials, and then we calculate inverse factorial of n minus 1, and that is log of mod, because we use binary exponentiation here. But now we again use a single loop, so we'll again have an O of n. So we can actually say that this is of the order n, because log of mod will actually be quite smaller. So we can actually do this preprocessing in O of n. And now calculating NCR is actually quite easy. If r is greater than n, we can simply return 0. Otherwise, we know that NCR is n factorial upon r factorial upon n minus r factorial. So we'll multiply factorial of n with inverse factorial of r with inverse factorial of n minus r, and that will give us NCR. So now we are actually forming the list f, which was storing all the frequencies. So we'll iterate over all the elements of array and do m of I plus plus, that is m of I actually stores the frequency of I in our array. So again we iterate over the vector and push the frequencies in our vector v. So now we'll sort our vector v, that is we'll sort the frequencies. We assign answer as 0, and we loop over the frequencies f, which I described. So f, this is actually the frequency of all the elements in my subsequence. I'll assign result as 1. Now I'll iterate over the vector only for the elements which are greater than or equal to I, because for less than I, their contribution will only be 1. So for example, if our list was 2, 3, 7, 8 and current I is 4, we'll only consider elements 7 to 8. And since our list is sorted, we'll use lower bound, and lower bound actually returns the smallest value which is greater than or equal to I. So for example, if I is 4, the smallest value which is greater than or equal to 4 is 7. So it returns a pointer to this element, and so we'll start from here and move till the end of the array. And now the contribution of any element will be 1 plus star it is the value at this pointer, which is fi c f, and finally we will add res minus 1 to our answer and simply return answer. So as you can see that the total time complexity will be O of n. Also we have binary search here, so this will be O of n log n, and the space complexity will be O of n, because we are only calculating the factorials, inverse factorials, and a map of frequencies of all the elements. So I hope the idea was clear to you. If you like the video, please hit the like button, And for more such amazing videos, subscribe to our channel. Thank you for watching this video. Hey guys, I am Bhavya. This is the second video of code drift on maths. So in this video, I will discuss the easy problem and the hard problem. So let's look at the easy problem first. So Batman and Robin are on a mission. There is a bomb which they want to defuse, but the problem is they will have to solve a task first, which is very difficult for them. As you are their friend, they ask you to solve the problem for them. You are given a pair a comma b. After each operation, pair ab gets changed to b minus 2a comma 2b plus a. You are given the initial values of a and b, and you need to find and return the value of the pair after cth operation. A, b, c are around 10 to the power 9, and you need to return the value modulo 10 to 9 plus 7. So for example, if a is 5, b is 10, and c is 2, so initially the value is 510. After doing one operation, the value will be 0.25, and then again we do an operation, 0.25 will be changed to 25.50. So final answer will be 25.50. So let's look at the module solution. So as per our operation, a comma b is changed to b minus 2a and 2b plus a. So let's actually look how the values change. So initially the value is a comma b. After doing an operation, the value will be b minus 2a comma 2b plus a. If we do one more operation, the value of a will be b minus 2a, and b is 2b plus a here, minus 2 into a, where a is b minus 2a. So this will be 5a, and the value of b will be 2b plus a. So 2 into 2b plus a plus b minus 2a, which will be 5b. Again we do an operation, the value will be b minus 2a, which will be 5b minus 10a, and 2b plus a, which will be 10b plus 5a. Now again we do an operation, the value will change to b minus 2a, b is 10b plus 5a, minus 2 into a, where a is 5b minus 10a. So this will be 25a, and the value of b will be 2 into b plus a, where b is 10b plus 5a, plus a, and a is 5b minus 10a. So this will be 25b. So you can notice that after every two operations, the value of ab changes to 5a into 5b. So from ab we get 5a to 5b. Again, when we do two operations, we get 25a, 25b, and so on. So we can say that if c is even, the value of ab will be 5 raised to c by 2 into a comma 5 raised to c by 2 into b. But what if c is odd? So for example, if c is 5, then we will actually do four operations. That is, we will do c minus 1 operations, and we know that c minus 1 will be even. And then we will do one operation again. So for example, if we need to do 5 operations, we'll calculate the value at c minus 1, which is 4, and we know that the value at c equal to 4 will be 25a comma 25b. And now we'll simply do one operation to get the final value, which will be b minus 2a, and b is 25b minus 50a, and 2b plus a, which will be 50b plus 25a. So let's look at the code to understand it more clearly. So we assign null as 5 raised to c by 2 modulo m, where m is 10 to 9 plus 7, and we are calculating 5 raised to c by 2 using modular exponentiation, which can be seen here. And this calculating 5 raised to c by 2 will take log of c by 2 time using binary exponentiation. Now the value of a will be a into 5 raised to c by 2, the value of b will be b into 5 raised to c by 2. We assign answer as a comma b. If c is even, then we are done. We found the answer. If c is odd, we need to do one operation one more time. That is, we'll change the first value as b minus 2a, and we'll change the second value as 2b plus a, and we'll finally return answer. So the time complexity will be log of c, because we just need to calculate 5 raised to c by 2 and all other operations are constant. So let's actually look if it works. Let's submit it. So we'll test it. So it works here, and now submit it. Okay, so it works. So now I'll actually describe a solution which can do it for any p and q. So for example, from AB, we could have done it for any PA plus QB and RA plus SB. If this was our operation for any PQRS plus SB, still this problem was solvable. This could have been done using matrix exponentiation. So let's actually look the problem, the original problem. So initially the values are AB, and let's say after doing one operation, the values will be A dash B dash. So we'll represent A dash B dash in terms of AB. So this will be minus 2 comma 1, because A dash will be minus 2A plus B, and B dash will be A plus 2B. So I'll write 1 comma 2 here, 1 2. So this is our matrix. And let's say we do one operation on A dash B dash as well. That is, we do total 2 operations. So A dash B dash will be minus 2 1 1 2 A dash B dash. But notice that this is equal to this value. So by replacing it, we'll get minus 2, 1, 1, 2 square AB. So that is the value after doing two operations. So we can say that if we do C operations, the final value will be minus 2, 1, 1, 2 raised to C into AB. So these are the coefficients as per our problem. So even if we are given some random coefficients, we could actually calculate it using matrix exponentiation and finally calculate the values of A and B. Now let's actually prove that why the values become 5A, 5B after doing two operations. So we can actually, why the values 5 raised to C by 2 into A and 5 raised to C by 2 into B when C is even. So let's actually consider that C is even. So we can write this as minus 2, 1, 1, 2 square raised to C by 2 into AB. So I'll square this matrix. So minus 2, 1, 1, 2 into minus 2, 1, 1, 2 will be, so this will be 4 plus 1, 5. And this will be minus 2 plus 2, 0. Minus 2 plus 2, 0. 1 plus 4, 5. So we can write it as 5 into I, where I is the identity matrix, 1, 0, 0, 1. So we can say that this is 5I raised to C by 2 into AB, because this square is 5I. So we can write it, and we know that I raised to any power P is equal to I. So because I is the identity matrix, so we can write it as 5 raised to C by 2 into I, and we know that I is 1, 0, 0, 1 in times AB. So the final value will be 5 raised to C by 2 into AB. So that's the proof that why the values become 5 raised to C by 2 into A and 5 raised to C by 2 into B. So you could either do it using matrix exponentiation or observe the pattern in this problem. So now let's look at the second problem, the hard problem. So India and Pakistan are playing a bilateral series of A matches. Now you know that India won exactly B matches. We know that there are ACB ways in which India could win B out of the A matches played. Here NCR is the number of ways to select R objects out of N objects. Having known that, we want to know the number of possible results in which the maximum consecutive number of matches lost by India is exactly K. We need to find that count for all K from 1 to A minus B. Since the answer can be large, calculated modulo 10 to 9 plus 7. B is less than A, less than equal to 5, E5. So for example, if A is 5 and B is 2, that is India played 5 matches and won 2 out of them. So we have 5C2 ways, 10 ways. And you can see that there is one way in which India will lose only one consecutive match maximum times, that is loss, win, loss, win, loss. And you can see that there are 10 ways, and there will be one way in which India could lose maximum one consecutive match. There are 6 ways in which India could lose maximum 2 consecutive matches, and there are 3 ways in which India could lose maximum 3 consecutive matches. So we need to return that array. So let's look at the model solution. So the prerequisite for solving this problem was inclusion and exclusion. So if you don't know about inclusion and exclusion, try to read it first and then look at the solution. So the idea was that if India wins B matches, then there will be some B plus 1 gaps. So if these are B wins, then there will be W plus 1 gaps. So let's actually call the gaps as GI. So this will be G1, G2, G3, G4, G5, and so on up till G of B plus 1. So for example, if total number of matches played were 5 and India won 2 matches. So if B is 2, there will be 3 gaps, G1, G2 or G3. So these gaps actually denote the number of consecutive matches lost by India, because we have placed all the win here, all the B wins here, and the remaining gaps will be of losses. So from here we know that there will be B plus 1 gaps. So G1 plus G2 and so on up till G B minus 1, B plus 1. That is the total sum of gaps will be A minus B, because the total number of matches played are A and India won B out of them. So the total number of losses will be A minus B, and these gaps actually denote the losses. So now our problem was, given a K, we need to find the sequences where maximum consecutive matches lost is exactly K. So what we'll do is we'll actually calculate answer of K, but answer of K is number of sequences where maximum consecutive matches lost is at most K. So for finding the sequences where the maximum consecutive matches lost is exactly K, we will calculate answer of K minus 1, because it contains all the sequences where maximum consecutive matches lost is less than equal to K, and this contains all the sequences where maximum consecutive matches lost is less than equal to K minus 1. So this difference will contain all the sequences where maximum consecutive matches lost is exactly K. So now we will calculate answer of K for all the Ks. Now given a K, the maximum consecutive matches lost is at most K. So that is equivalent to saying that Gi is less than equal to K. So we have this additional constraint that Gi is less than equal to K, and G1 plus G2 so on up till Gb plus 1 is A minus B. So this is our equation, that is the solution to this two equations will give us answer of K. Now how to do that? So let's actually ignore this constraint first. Let's ignore this constraint. How many solutions does G1 plus G2 and so on up till GB plus 1 equal to A minus B have. So this is actually a popular problem called stars and bars problem. So that is, if we have, let's say, A1 plus A2 and so on up till AN is equal to S, we are given some solutions to this equation are, the total number of possible solutions to this equation are S plus N minus 1, C N minus 1. Now, to give an intuition of why this is so what we do is, let's say we have S stars, and we take, so for example, if S is 6, we have S stars, and N is 3. So what we do is, we place 2 bars, we select 2 bars, that is, we select N minus 1 bars. So we are saying that the total number of solutions to this will be the number of ways to permute the stars and bars. So the number of ways to permute this will be S, where S is 6 here, so S plus, and the total number of bars will be N minus 1, so S plus N minus 1, C, N minus 1 or S. Now why this is so? So consider any permutation. So we have star, then a bar, then again a bar, and let's say we have the remaining stars. So what it does is, the values between the bars will be the value of AI, because this bars will divide the stars into, so if we have n minus 1 bars, this will divide the stars into n parts. So for example, here we have 2, here we have 0, and here we have 3. So any permutation will give us the solution to this equation. So that was the general idea behind this. So the solution to this is S plus N minus 1, C N minus 1. So now, if we ignore this constraint where Gi is less than or equal to K, the solution to this equation will be S, where here S is A minus B, plus N minus 1, here N is B plus 1, so N minus 1 will be B, C, B. So the total solutions to this equation is ACB, which was obvious because if we ignore this constraint Gi less than or equal to K, then it is equivalent to saying that we are considering all the possible ways of India winning B matches out of A matches played. But now we have this additional constraint that Gi less than or equal to K. So what we'll do is, we'll use the idea of inclusion and exclusion. So we'll subtract the sequences where Gi gets greater than K for exactly one element. So let's say we choose any element B plus 1 C1. We have B plus 1 C1 ways to choose any element, and we will assign Gi. We want that this item selected should have the value greater than K. That is, its value should be at least K plus 1. So what we'll do is, we will write that Gi as Gi plus K plus 1. So that is equal to saying that our equation now becomes G1 sigma Gi is equal to A minus B minus K plus 1. And the solutions to this equation are A minus K plus 1, C, B. Now we will add the sequences where the number of Gi is greater than K is exactly 2. So this will be B plus 1, C 2. And now, using similar observation, this will be A minus B minus 2 into K plus 1, because we will assign this to 2 Gi's. And we have B plus 1 C2 ways to select that 2 indices. So this will be A minus 2 into K plus 1 CB. And now we'll subtract sequences where we have 3 Gi's greater than K. So this will be B plus 1 C3 into A minus 3 into K plus 1 CB, and so on. So we can write this as minus 1 raised to R. R is from 0 to some value. We'll find the upper bound here. And this will be B plus 1 CR into A minus R into K plus 1 CB. So this will be our formula for finding for a given K. And now what will be the upper bound? So we want that A minus R into K plus 1 should be greater than or equal to B for this to be valid, otherwise NCR will be 0. So the value of R will be less than or equal to A minus B upon K plus 1. A minus B upon K plus 1. So the upper bound is A minus B upon K plus 1. So referring the previous video, we can calculate NCR in O of 1 by pre-storing the factorials and inverse factorials. So calculating this answer for a fixed K will take A minus B upon K plus 1 time. So if we sum it for all the K's from 1 to A minus B, this will actually be A minus B log of A minus B, because we can take this A minus B out. So this will be A minus B into sigma 1 upon K plus 1, where K ranges from 1 to A minus B. And we know that the sum of this harmonic series is log of A minus B. So the total time complexity of calculating this formula is A minus B into log of A minus B. So this gives us answer of K. And for finding the sequences where the total consecutive matches, maximum consecutive matches lost is exactly K, we will simply do answer K minus 1 as told previously. So let's actually look at the code, and this will be more clear. So this part of code is actually similar to the previous problem. This all it does is actually stores the factorials and inverse factorials and give us a way to calculate NCR in O of 1. So we'll use preprocess, and preprocess was already described previously. So let's say I have assigned N as A and K as B, and previous actually stores the value of answer of K minus 1. That is M minus 1 here. So instead of K, I'm using M in the code now. So we know that the value of K will be from 1 to a minus b, which is n minus k here, and we are saying current is 0, will iterate from 0 to n minus k upon n plus 1, which is equal to saying that we are iterating from a minus b upon k plus 1. And now answer will be k plus 1 cr into n minus m plus 1 into r ck, that is b plus 1 cr into a minus r into k plus 1 cb. So we also have to consider this term minus 1 raised to r. So if r is odd, we will decrease this value, current minus equal to temp, else current plus equal to temp. And now we know that the answer is current value minus previous value, answer of k minus answer of k minus 1. So current minus previous plus m modulo m, and we will simply return answer. So let's actually submit it and check if it works. So let's submit, and it works for all the cases. So I hope the problem and the idea was clear to you. So the next contest will be based on binary search. And again, I think the hard problem will be interesting and for some people. So if you like the video, please hit the like button and please subscribe our channel for more such videos. Thank you for watching this video.